Streamlining C/CD with AWS CodeCommit and CodeBuild, a Terraform-Driven guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction. Why AWS CodeCommit over GitLab? In DevOps, continuous integration and continuous deployment, C/CD, are essential practices for accelerating software development and ensuring high-quality code delivery. When considering a version control system for hosting your code repository, both AWS CodeCommit and GitLab offer potent solutions. However, AWS CodeCommit, a fully managed source control service, offers seamless integration with other AWS services, making it an attractive option for teams already invested in the AWS ecosystem. This podcast will guide you through building a primary C/CD pipeline using AWS CodeCommit and CodeBuild, leveraging Terraform for infrastructure as code, IAC. Terraform backend configuration, S3 and DynamoDB for state management. Before diving into the pipeline setup, it's crucial to establish a reliable Terraform backend for state management. Using Amazon S3 to store the Terraform state files and DynamoDB to store state locking ensures consistency and prevents conflicts during concurrent Terraform executions. Steps to configure the Terraform backend. Create an S3 bucket. The Terraform state files will be stored in the S3 bucket. To prevent accidental deletions or overwrites, ensure that versioning is enabled. Resource AWS_S3_bucket Terraform_state. Bucket equals my Terraform state bucket. Versioning. Enabled equals true. Create a DynamoDB table. The DynamoDB table will handle state locking to prevent simultaneous updates to the state file. Resource AWS_DynamoDB_table Terraform_locks. Name equals Terraform locks. Billing_mode equals pay_per_request. #_key equals lock ID. Attribute. Name equals lock ID type equals S. Configure Terraform to use S3 and DynamoDB. Modify your backend configuration to use the S3 bucket and DynamoDB table. Terraform. Backend S3. Bucket equals my Terraform state bucket. Key equals path/2/my/terraform.tf state. Region equals us west 2. DynamoDB_table equals Terraform locks. Setting up the AWS provider and IAM roles. With the backend configured, the next step is to set up the AWS provider and IAM roles necessary for your C/CD pipeline. Terraform will manage these resources, ensuring consistent and repeatable deployments. Defining the AWS provider. Provider AWS. Region equals us west 2. Creating IAM roles. CodeCommit role. This role allows CodeCommit to access necessary AWS services. Resource AWS_EAM_role CodeCommit_role. Name equals CodeCommit role. Assume_role_policy equals EOF. Version, October 17, 2012. Statement. Action, STS assume role. Effect, allow. Principle. Service, codecommit.amazonoz.com. EOF CodeBuild role. This role allows CodeBuild to perform build tasks and interact with other AWS services. Resource AWS_IAM_role CodeBuild_role. Name equals CodeBuild role. Assume_role_policy equals EOF. Version, October 17, 2012. Statement. Action, STS assume role. Effect, allow. Principle. Service, codebuild.amazon.com. EOF. Creating an AWS CodeCommit repository, IaaS versus GitLab's managed approach. AWS CodeCommit, unlike GitLab's managed repositories, offers infrastructure as a service, IaaS, with the advantage of tighter integration with AWS services like CodeBuild, CloudWatch, and IAM. This makes it ideal for teams leveraging AWS's extensive cloud capabilities. Creating the CodeCommit repository with Terraform. Resource AWS _CodeCommit repository my repo. Repository name equals my repo. Description equals my sample repository for C/CD pipeline. Defining the C/CD process, CodeBuild and buildspec.yml. AWS CodeBuild is a fully managed build service that automates building and testing your code. The buildspec.yml file, which defines the build steps, is critical to this setup. Sample buildspec.yml configuration. Version 0.2. Phases: install. Commands: echo installing dependencies. Pip install requirements.txt. Build commands: echo building the project. Python build.py. Post_build. Commands: echo build complete. Artifacts, files. Connecting CodeCommit and CodeBuild, the role of CloudWatch events. To automate the build process, you must trigger CodeBuild every time a new commit is pushed to the CodeCommit repository. Setting up CloudWatch events can achieve this. Creating a CloudWatch event rule with Terraform. Resource AWS _CloudWatch _event _rule CodeCommit _push. Name equals CodeCommit push event. Description equals trigger code build on CodeCommit push. Event _pattern equals EOF. Source, AWS.CodeCommit. Detail type, CodeCommit repository state change. Detail. Event, reference updated. Reference type, branch. Reference name, main EOF. Resource AWS _CloudWatch _event _target trigger _CodeBuild. Rule equals AWS _CloudWatch _event _rule.codecommit push.name. ARN equals AWS _CodeBuild project.my build project.arn. Fine-tuning permissions, IAM roles for CodeBuild and CloudWatch events. To ensure that the C/CD pipeline operates securely, it's crucial to fine-tune IAM roles, granting only the necessary permissions for CodeBuild and CloudWatch events. IAM policy example for CodeBuild. Resource AWS _EAM _policy CodeBuild policy. Name equals CodeBuild policy. Description equals policy for CodeBuild permissions. Policy equals JSON encode. Version, October 17, 2012. Statement. Action. S3 get object. S3 put object. Effect, allow. Resource. Resource AWS _IAM role policy attachment CodeBuild attach. Role equals AWS _IAM role.codebuild role.name. Policy _ARN equals AWS _EAM policy.codebuild policy.arn. Conclusion. Reflections on the Terraform-Driven AWS C/CD setup. Building a C/CD pipeline with AWS CodeCommit and CodeBuild, managed through Terraform, provides a robust, scalable solution that integrates seamlessly with the AWS ecosystem. This approach offers greater control over your infrastructure and enhances security and automation capabilities compared to traditional managed C/CD solutions like GitLab. Adopting a Terraform-driven approach ensures your infrastructure is version-controlled, repeatable, and easy to manage. This makes it ideal for teams looking to streamline their DevOps processes within the AWS environment. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.